Hello, welcome back. We are looking at more area type problems, area of rectangles. Here we're given a rectangle A and rectangle B. So if A were to double its width to become figure B, so it starts as figure A and then it grows in size. It becomes twice as wide to turn into figure B. So it asks, what is the area of figure B? Now, of course, we could count these out, but try to get in the habit of thinking through this. So think if you could cover this up. If it has a width of 2, if it doubles its width, the new width would be, what would it be? 4, okay? So if this starts out as a 2 by 1, 2, 3, 4 triangle, so we have 2 times 4 would be 8. Now if we doubled the width only, the height of the new rectangle would stay the same. So the height would still be 4. But what would have happened if we doubled the width, the thing that changed, I'll maybe do that in a different color here. If the new width was 4, then it would be a total area of 16. Okay, let's try that again, and I'm going to just cover it up just to see if we could think through it. So figure A has an area of 12, and if figure A lost 2/3 of its height to become figure B, what would be the area of figure B? So let's divide the height into thirds. Okay, so if there's a total of 1, 2, 3, 4, 5, 6, what is a third of 6? So I'm actually going to cut this into thirds. All right, so it currently has 1, 2, 3 thirds. It has all of its thirds. If it lost 2 of its thirds, what would be left? It would only be a square here of 2 by 2. And what would that area be? It would be 4. So it would go from an area of 12 to an area of 4. We can picture that easy enough, but I want you to think of how that would look. What if we did 12 times a factor of 1/3? Well, that would be like 12 over 3, or 4. Okay, see how we're connecting those ideas of counting shapes and working with fractions. And that is the goal of that problem. Let's continue on and extend what we just talked about there in this problem. So we have a pattern. Okay, so total area in square feet. If we have a figure of a length of 10 and a width of 1, 2, unknown, or 4. Okay, do we see kind of what's happening here? So if we have a figure that is 1 times 10, right, a width of 1, that would be a width of 1 and a height of 10. 1 times 10 is an area of 10. What if it was 2 times 10? So we have another rectangle that might look something like this. In this case, you could kind of picture using our base 10 block. So this would be a width of 2. Still has a height of 10. So what would the area be? I'll do A equals for area. So in this case, 2 times 10 would be 20. So area would equal 20. So what would I fill in for A there? 20. How about over here? So let's think of a scenario where we would have, again, a height of 10. We don't know how wide, right? The height is 10, and the area is 30. So before, if we did 2 times 10 to get 20, how could we find the unknown width here? Well, we would do 30 divided by 10 and get a width of 3. So C would be 3. to draw that, it might look something like this. Like 3 10 blocks, 10, 20, 30, and that would find our area. How about one last time? So in this case, well, we can see the pattern that we're keeping a height of, well, let's say we don't see that pattern yet. We know the base is 4, and we know that area equals 40. Okay, so we would use the same formula where over here we did length times width, or 1 times 10 to get 10, 2 times 10 to get 20. Over here we did 30 divided by 10 to get 3. So here we might do 4. We're going to use the area of 40, do 40 divided by 4 to get a height of 10. Okay, and then we were able to b equals 10. Fill in all of those. So we want to select all of the true answers. Well, we found A to be 20. We found B to be 10. And we found C to be 3. Notice we were kind of following this pattern here as well, that we could see 10, 10, 10, 10, 10 blank, 30, 40, so 10, 20, 30, 40. Makes sense. 1, 2, blank, 4. 1, 2, 3, 4. So connecting multiplication and area and patterns in that problem. All right, how about this one? So we're going to do a similar thing, but be careful at the end. They want to know what the value of A plus C is, okay? So it's really easy in these problems to go, once we find what C is or A is or X is, to circle the answer. But we have to be very patient and see what they're actually asking. Lots of problems like this on these tests. Okay, so let's fill this in. What are we doing here? So we have 3, 5, blank, blank. Up here we have 4 blank, blank, blank. So if it looks like in this case it's following the pattern where the length is staying 4. So let's see what this, we know all the information here. So it's a width of 3, height of 4, to get an area of 12. Okay, that's this first one. This next one is 5 times blank equals B. I'll follow the assumption that we also have a height of 4, since if we follow the pattern, all of the lengths in this case are 4. So 5 times 4 would give us an area of 20. Okay, so what is the missing area? This is also B, right? So area in this one is 20, or we can say B is 20. I'll write 20 here. Okay, now we're following the pattern. It's interesting. So 12, how do we get from 12 to 20? That would be adding 8. How do we get from 20 to 28? Add 8. And 28 to 36? Add 8. So see the pattern? So in this case, we're going up by 8 each step. In this length row, we're staying consistent at 4. So if we were to look for patterns, let's see if we can solve question 4 in 2 different ways. So to go from 3 to 5, I added 2. So if we assume that the pattern is going to be consistent, let's see if the theory holds up. Plus 2 to get 5 plus 2 would be 7. I'll put that down here. And plus 2 again. So 7 plus 2 would be 9. Let's see if that holds up. So 28 divided by 4, does that give us 7? It sure does. 36 divided by 4, does that give us 9? It sure does. Okay, so that's a couple different ways we can solve that one. Now before we get tempted to put 3 or 4 or 11, which of these would be the correct answer? We really want to know what A plus C is. We found C to be 4 and A to be 7. So they're really asking us to add those together to get 11. And there we have it. Okay, great job, and I'll see you next time.